Hey guys, Mr. Reese here to help you out on your 3.7 calculus homework. So I'm not going to do the problems, but I'll help you guys set them up right here. So hopefully you guys can use that to find some interesting things, can help you answer some questions, and you'll actually see that a lot in worksheet A. So in worksheet A, the first problem is find the length and width of a rectangle that has a perimeter and a maximum area. So yeah, you could just make up something and make, like a 10 by 30 rectangle and that have an area of 300. Or what we want to do here is to think we have a rectangle, and rectangle is x by y all the way around. So the area we want to maximize is x times y, but we don't ever want to take like the derivative of something, if we can go through and replace. So since we know that the perimeter, which is 2x plus 2y, because there's two x's going around and two y's, that's the worst looking y ever, that has to equal 80. We can get the y by itself and substitute it in there. So let's see, 2y would equal 80 minus 2x. And then if we divide by 2, we'd get y equals 40 minus x, because we can divide both of those by 2. So let's replace that back into our area problem here. And so what you're going to do is get the area equals x times 40 minus x. Okay, so I'm going to kind of pause there. I'll tell you what you'll need to do next. So in this problem here, you got it set up. We got our constraint here that we used to substitute into the problem we're trying to maximize. We got our equation. Now we might want to go through and distribute this to make it easier equation, but what you want to do when we find any maximum, it's when the derivative equals 0. So you have the equation here, you're going to take the derivative, find it, set it equal to 0. You might get two answers here. You might get one positive and one negative. Actually, no, you probably should only get one answer. But you're going to plug that answer in to figure out your x and y. All right. So you're going to notice something very, very special about that once you plug it back in to get your x and y. That will give you a clue on how to do the next three problems. Okay. Let me help you out on the third one though. So you don't have to do that, but we'll do the next one here. And this problem here, very similar. We have the length and width of a rectangle again. So we can say x times y. But what we want to do is to minimize the perimeter. So the area has to be 32 square feet. X times y equals 32. But what we want to minimize is the 2x plus 2y, because that's the perimeter. So what we want to do is here, let's get y by itself. So y equals 32 over x. And you can plug that in. 2x plus 2 times 32 over x. Okay, so in this problem here, just like the other one, we have our perimeter. You're going to take the derivative of it, set it equal to 0. All right. Once you get that number, you're going to plug it back in, and you should notice something very special about that shape again, and that should help you set up our answer, problem 4. Okay, so there is worksheet A. Next, what we're going to do is take a look at worksheet B. All right, worksheet B. Oh, come on, pop, please. There we go. All right, so I'll go through each one of these problems to help you guys set these up. So we got a rectangle page that contains 30 square inches of print. The margins on each side are 1 inch, and the dimensions, find the dimensions that use the least amount of paper. Okay. So what we have in here, a couple different ways to look at this. But, sorry, phone's going crazy. We got 30 square inches of print here, and it's a rectangle, so this is like x by y, And it says the margins on each side are all 1 inch. What we want to do is like, how wide is this and how long is this or high is this, width and height. What's the dimensions to make the smallest rectangle possible to still get 30 square inches here? Okay, so we want to go through and we want to minimize the area of the big square. So area, which would be, okay, this whole width would be x plus 2, right? Because we have it's x along plus 1 on this side and plus 1 on the other side. And then the other side here is our y, which is y plus 2. So just like in the last problem, we're going to have to set up our constraint. Our constraint is that x times y has to equal 30. So this inside part here has to equal 30. So what we can do is to substitute, say y equals 30 over x. So our area is x plus 2 times 30 over x plus 2. So we're going to take the derivative of that and set it equal to 0. Very similar problem here. A rectangular page contains 30 inches of print and the margin on each side fine. Okay, so just like the last problem we did there here, so that should help you out. I mean, the only thing difference, this is going to be 36, and we got 1.5 on each side. So still it's going to be x, y equals 36. So y equals 36 over x. And the area would be x plus, well, if we got 1.5 on each side, that'd be 3, and y plus 3. Okay, so just like the last problem, you're going to plug that in. So not too bad. All right, here we go. This farmer tries to make an adjacent, he needs to contain that much. So that's our constraint. So x times y equals 245,000. What we want to do is minimize the amount of fencing he would need. All right, so to minimize the amount of fencing, we're going to look at the perimeter, right? Which it's not 2x, 2y because he doesn't need the x along the river. It's just going to be 1x plus 2y. So if we can get the y by itself, we can divide it by x. And so our perimeter would be x plus 2 times 245,000 over x. Okay, so what we want to do, like in all our problems so far you've seen, we take the derivative, set it equal to 0. Plug that back in. So you want to make sure that you do name the dimensions too. All right, now let's look at worksheet C, the third worksheet that we're going to do. All righty, so here we go. This one gets a little bit more complicated because since we're dealing with 3D things. A rectangle solid has a square base. Man, I'm so good at drawing rectangles. X by x. And it has a surface area of 337.5. What dimensions will hold the maximum volume? So volume is going to be x times h, because that's the height. All right, so we got to change this h and substitute out. Let's get the surface area here. The surface area, if you think about, is, well, we'd have x by x, and we'd have two of them, one for the top and one for the bottom. So we got 2x squared, and then plus we would have an x by h on the front, back, and then even on the left and right, so 4x by h's. That's got to eat the 337.5. So we can get this h by itself by first subtracting the 2x squared and then dividing by 4x. All right, so the volume formula here would be, let's say this would be x squared, right? X times x is x squared times 337.5 minus 2x squared over 4x. Okay, so I would recommend distributing that, make it easier. Well, once you have that, you'll take the derivative of it, set it equal to 0. Figure out what that number is and plug it back in to all three sides. All right, next we got a Norman window, which is a semicircle on top of a rectangle here. The dimensions, find the dimension of the normal of the maximum area with a total perimeter of 16 feet. Okay, so when they say perimeter, I'm going to assume they're talking about that part there. So if we think about this perimeter is going to be our constraint. We have an x plus 2y plus, and then right here is a semicircle. A full circle is 2 pi r for the circumference. So this part here is just pi r. All right, so the maximum area, if we want to maximize this area here, our area is x times y and then plus pi times r, which is x over 2, squared. And then actually we're going to cut that in half because it's a half a circle, so pi r squared. Okay, so let's talk about the constraint here. We know the perimeter's got to equal 16. So let's get this y by itself and go through. So see, 2y would equal 16 minus x, and then minus, oh, I kind of messed, that should be x over 2, because the radius, pi. And then we can divide that all by 2. So we can actually, if we divide that all by 2, 16 divided by 2 is 8. 1x divided by 2 is a half of x, and x over 2 pi would be actually pi over 4x. Got the x there. All right, that's what we can substitute in here. So it gets a little messy. We got x times 8 minus 1/2 x minus pi over 4x. And then plus, and then here, I'll help you guys out on this one here. If we take pi, and then we squared this x, so that's going to be x squared. We square that 2, it's 4, and then times it, that'd be pi over 8x squared, or 1/8. Okay, so just like before, that gets a little complicated here, but you're going to take the derivative of it, set it equal to 0. So I would definitely clean this up as much as you can. It's going to be all right. All right, last problem. This one's easier. All right, we have a rectangle that's bounded. Now, our rectangle has an x location and then the y up here. So if we want to find the maximum area, we want to go through and do area equals x times y. Well, the nice thing is that this constraint here, it has to be along this line, and then we already have the y by itself. So all we need to do for this last problem is plug in that equation. All right, so you can distribute that out, make it nice. All you got to do is distribute it to the top there. Take the derivative of that equation, set it equal to 0. So the last problem, not too bad. Definitely that Norman problem is the worst. But remember, the answer keys are available for you on Canvas, and you can check those out. All right, guys, so there's the homework help with 3.7. We got review for you, and then we'll have a quiz for you guys to take after this. So nice short section before we jump into chapter 4. All right, guys, have a great day, and I will see you next time. See ya.